Hello everyone. In this video, we will learn about one of the concepts of matrices, the transpose of a matrix. The transpose of a matrix is one of the most commonly used methods in matrix transformation. In this video, we will learn the definition of the transpose of a matrix, steps to find the transpose of a matrix, properties of transpose of a matrix, and we will do few examples with complete explanation. So the definition of the transpose of a matrix. For any given matrix, the matrix obtained by interchanging the rows into columns or columns into rows is called the transpose of a matrix. Whenever we are given any matrix, a matrix of any order is given to us, we need to change the rows into columns or we need to write the columns as rows. Then the resultant matrix obtained is called the transpose of a matrix. So in simple way we can define for a given matrix, the transpose of a matrix is obtained by changing the rows into columns or columns into rows. If A is any matrix, then the transpose of A is denoted by A power T or A dash. So this is how we denote the transpose of a matrix. Either we write A power capital T or we write A dash. So let us see one of the examples of how to find the transpose of a matrix. Suppose we are given a matrix A as 1, 2, 3, 4, 5, 6. Remember there are two rows. The horizontal lines are called as rows and the vertical lines are called as columns. So there are two rows and three columns. We can write the transpose by changing the rows into columns or by writing the columns as rows. So here what we will do, we will write the first row as the first column. So this becomes the first row 1, 2, 3 becomes the first column 1, 2, 3. The second row 4, 5, 6 becomes the second column 4, 5, 6. This is called as the transpose of the given matrix A. Either we write A power T or you can write A dash as well. Whichever way you feel comfortable, you can write A transpose. So you can see the 2 by 3 order has now become 3 by 2. 3 rows and 2 columns. So the transpose is obtained either by writing rows as columns or by writing columns as rows. Let us see another example. So the other example is the matrix can be of any order. Let us take a square matrix of order 2, 2 rows and 2 columns. 2 by 2 is the order of this matrix. You can write the transpose either as A power T or A dash. You just need to write the rows as columns or you write the columns as rows. So we will write the first row as the first column and the second row as the second column. So this is called as the transpose of a matrix. Since this is a square matrix of 2 rows and 2 columns, the transpose will also be of same order. So you can find or you can write the transpose of any matrix by changing the rows into columns or by writing the columns as rows. Either you write rows as columns or you write columns as rows. The resultant matrix is called as the transpose of a matrix. So let us now see the properties of the transpose of a matrix. The first property says A transpose whole transpose is equals to A. That means for any given matrix you write the transpose, again you transpose it, the transpose of a transpose matrix will be equals to the given matrix. The second property says A plus B whole transpose and A transpose plus B transpose will be both equal matrices. Either you first write A plus B, add A and B and then write the transpose, or you write A transpose and B transpose and then add, both will be the same matrices. The third property says AB whole transpose, A into B. You multiply A and B matrix together, then write the transpose, or you write the transpose of B and transpose of A and then multiply, then both of these will be equal. AB whole transpose and B transpose A transpose will both be equal matrices. And the fourth property is K into A whole transpose will be equals to K into A whole transpose. K is any scalar here. K can be any scalar, any constant value. Okay, K is any scalar, we can say any constant value. For example, you can say you have 2 into A whole transpose. So first you write A transpose and then multiply with 2, both will be same. Either you write 2A and transpose it, or you write the transpose of A and then multiply with 2, both of these will be equal. So these are the properties of transpose of a given matrix. First one is A transpose whole transpose equals to A, that is the transpose of a transpose matrix is given matrix. A plus B whole transpose and A transpose plus B transpose both will be equal. AB whole transpose or B transpose into A transpose will be equal. K into A whole transpose is equals to K into A transpose, where K is any scalar. Let us see a few examples on transpose of a matrix. This is one problem. If A equals to -2, 1, 0, 3, 4, -5, B is a matrix 1, 2, 4, 3, -1, 5, then find A plus B whole transpose. So we are given matrix A and matrix B. We are asked to find the sum of A and B transpose. So let us first write down what is given to us. We are given matrix A is equals to -2, 1, 0, 3, 4, -5. And matrix B is given as 1, 2, 4, 3, -1, 5. We are asked to find the sum of A and B transpose. So first let us write the transpose of B. Remember, the transpose of B is denoted as B power capital T, and it is obtained by either interchanging the rows into columns or columns into rows. So here we will interchange the rows into columns. First row is 1, 2. We will make the first row as first column. We will change row into column. Second row 4, 3 will become the second column 4, 3. Third row -1, 5 will be converted into the third column -1, 5. So now we can add both because A and B both are of same, A and B transpose are of same order. A has 2 rows and 3 columns. B had 3 rows and 2 columns. So directly addition was not possible because addition is possible only when both the matrices are of same order. So when we write the transpose of B, we get 2 by 3 as the order of B transpose. So A and B both, A and B transpose both are of same order now. So we can add both A and B transpose. So let us write both the matrices here. This is matrix A -2, 1, 0, 3, 4, -5 plus the matrix B transpose 1, 4, -1, 2, 3, 5. So we are adding both these matrices. Addition is done purely on the basis of adding corresponding elements. So we need to add the corresponding elements. The first element of first row and the first element of first matrix and the first element of second matrix. So we need to add on the basis of corresponding elements, minus 2 plus 1. Then the second element of first matrix is 1 plus the second element of second matrix is 4. Third element of first matrix is 0 plus the third element of second matrix is minus. Same way, fourth element 3 plus the fourth element of second matrix is 2. Then the next element is 4 plus the next element of second matrix is 3. And the last element of first matrix plus the last element of last matrix. So addition is done purely on the basis of corresponding elements are added together. First element of first matrix plus first element of second matrix, second element of first matrix plus second element of second matrix. Same way corresponding elements of both the matrices are added together. So let us now write the sum. Minus 2 plus 1 is minus 1. 1 plus 4 is equals to 5. 0 plus into minus is minus. 0 minus 1 is minus 1. 3 plus 2 is equals to 5. 4 plus 3 equals to 7. Minus 5 plus 5 is equals to 0. So this is the value of A plus B whole transpose. So let's see one more example on how to find the transpose, and using transpose we have to find A plus A transpose and A into A transpose. So we are given matrix A here. Okay, let us write down first given matrix. Given A is equals to a 2 by 2 matrix. There are 2 rows and 2 columns here. The elements are 2, 4, minus 5, 8. We are asked to find what is A plus A transpose and what is the product of A and A transpose. So A is 2, 4, 5, 8. First we will write what is A transpose. Remember, transpose is obtained either by changing rows into columns or by changing columns into rows. So let us change the first row into first column and the second row into second column. So this is what is A transpose. First we want the sum of A and A transpose. So let us add both A plus A transpose. A is 2, 4, minus 5, 8 plus A transpose is 2, minus 5, 4, 8. Again, addition is done purely on the basis of corresponding elements. We put together the corresponding elements are taken together. The first element of first matrix, first element of second matrix. Then we take the second element of first matrix, second element of second matrix. So on that basis we do the addition. So first element of first plus first element of second matrix, second element of first matrix plus second element of second matrix. Same way third element of first matrix plus third element of second matrix, and the last element of first matrix plus the last element of last matrix. So let us write down the sum. The sum value of 2 plus 2 is 4, plus into minus is minus. So 4 minus 5 is minus 1, minus 5 plus 4 is minus 1, 8 plus 8 is 16. So this is the value of A plus A transpose. Now let us find the product of A and A transpose. A into A transpose. So A is 2, 4, minus 5, 8, and A transpose is 2, minus 5, 4, 8. Now this is multiplication of matrices. Multiplication is purely done on the basis of row into column. First row we multiply with first column, then first row we multiply with second column. So multiplication is purely done on the basis of row into column. So first element of first row with first element of, so unlike addition and subtraction where we take corresponding elements and add, here we multiply on the basis of row into column. So the first element of first row of first matrix into first element of first column of second matrix. 2 into 2 plus second element of row and second element of column here. This is how we multiply. Same way first row is multiplied with second column now. 2 into minus 5 plus 4 into 8. Then same procedure we apply with second row. Second row we multiply with first column. Minus 5 into 2 plus 8 into 4. Then second row with second column. Minus 5 into minus 5 plus 8 into 8. So 2 into 2 is 4 plus 4 into 4 is 16. 2 into minus 5 is minus 10 plus 4 into 8 is 32. Minus 5 into 10 is minus 5 into 2 is minus 10. 8 into 4 is 32. Minus into minus plus 5 into 5 is 25. Plus 8 into 8 is 64. So the product of the matrices A and A transpose is 20, 22, 22, 89. So the problem is if A is a matrix cos alpha, sin alpha minus sin alpha, cos alpha, we should show that A into A transpose and A transpose into A both are equals to I. I here remember is an identity matrix. So A is a 2 by 2 matrix of order 2 by 2. So identity matrix should also be of order 2 by 2. So let us consider what is given to us. We are given a matrix A. The elements are in terms of cos alpha, sin alpha, minus sin alpha and cos alpha. We need to first write the transpose of this matrix. Transpose is obtained by either changing rows into columns or columns into rows. So here we will write the first row as first column cos alpha sin alpha, and the second row we will write it as second column. We get the transpose of matrix A, that is A transpose. So we need to find what is the product of A into A transpose and A transpose into A. We have to show that both are equals to I. So let us first find what is the product of A and A transpose. So matrix A is cos alpha sin alpha minus sin alpha cos alpha. So this is A into A transpose. A transpose is cos alpha minus sin alpha into cos alpha. So multiplication, as we know, is purely based on row into column wise concept. So we don't take corresponding elements here. We take first row and multiply with first column, then we multiply first row with second column. Similarly, we multiply second row with first column and second row with second column. So the multiplication is done with column row into column ways. So cos alpha sin alpha is the first row here, cos alpha sin alpha is the first column here. So first element into first element, cos alpha into cos alpha, plus second element of first row here, second element of first column here, sin alpha into sin alpha. This is the first element. Okay, cos into cos plus sin into sin. Same way first row will be multiplied with second column here, cos alpha into minus sin alpha plus sin alpha into cos alpha. Then second row with first column minus sin alpha into cos alpha plus cos alpha into sin alpha. Then second row with second column minus sin alpha into minus sin alpha plus cos alpha into cos alpha. So what is that we have now? We have the first element cos alpha into cos alpha is cos square alpha plus sin alpha into sin alpha is sin square alpha. Second element cos alpha into minus sin alpha, we can write minus sin alpha cos alpha plus sin alpha into cos alpha is the second term there. So sin alpha into cos alpha. Then here we have minus sin alpha into cos alpha minus sin alpha cos alpha plus cos alpha sin alpha. And the last term minus into minus plus sin into sin is sin square alpha minus into minus becomes plus sin into sin is sin square alpha. Cos alpha into cos alpha is cos square alpha. Now we have cos square alpha plus sin square alpha here, so we can use the identity. We have the identity sin square alpha plus cos square alpha is equals to 1, the first identity of trigonometry. So sin square alpha plus cos square alpha we can write as 1. Here minus and plus both gets cancelled, we get 0. Here again minus term plus term gets cancelled, we get 0. And once again we have the identity to be used here, sin square plus cos square is 1. So 1 0 0 1, this is an identity matrix of order 2 by 2. So A into A transpose is equals to I. Therefore A into A transpose is equals to I. Similarly, we need to multiply A transpose into A and show that that is also equals to I. So the multiplication is done with A first and A transpose next. Similarly, here we need to write A transpose first and then matrix A, which will give us the identity matrix I. Let us now see the definition of couple of matrices which involves the transpose of a given matrix. Symmetric matrix. A square matrix A is said to be symmetric if A transpose is equals to A. A square matrix A is said to be symmetric if and only if A transpose is equals to A. We can also say a square matrix is called a symmetric matrix. A square matrix is called a symmetric matrix if the transpose is equals to itself. If the transpose is equal to itself. Okay, so any matrix whose transpose is equals to the matrix itself is called as a symmetric matrix. If A is equals to minus 1, 2, 3, 2, 5, 6 and 3x, 7 is a symmetric matrix, then find x. So we are given a matrix A which is symmetric. We have to find the value of x. Remember, a square matrix is said to be symmetric if and only if A transpose is equals to A. So, given A is equals to a 3 by 3 matrix minus 1, 2, 3, 2, 5, 6, 3x, 7. We are given this is symmetric. A is symmetric matrix. A is symmetric matrix implies A transpose and A both will be equal. So one side we will write the transpose of the given matrix. Remember, transpose is obtained by interchanging rows into columns or columns into rows. So here we will change the rows as column. First row we will write as first column. Second row we will write as second column. And third row we will write as third column. So this is the transpose of matrix A. On the other side we will write the matrix A as it is, minus 1, 2, 3, 2, 5, 6, 3x 7. So both these matrices are equal according to the definition that A is symmetric. So whenever A is a symmetric matrix, the transpose and the given matrix both will be equal. So when the matrices are equal, we can equate the corresponding elements. If you see the corresponding element, second element of third row here and second element of third row here, if you equate both these elements, you get the value of x is equals to 6. So the definition of another matrix which involves the transpose. So the other matrix is skew-symmetric matrix. Skew-symmetric matrix is nothing but a square matrix is said to be skew-symmetric if and only if the transpose of the given matrix is equals to the negative of the given matrix. Okay, a square matrix A is said to be skew-symmetric if and only if A transpose is equals to minus A. We can also put it like this: a square matrix whose transpose is equal to its negative. A square matrix whose transpose is equal to its negative is equal to its negative is called as a skew-symmetric matrix. So here we are given a matrix which is a skew-symmetric matrix. We are asked to find the value of x. So let us start with what is given to us. We are given a matrix A. So we will write given A is equals to a 3 by 3 matrix 0, 2, 1, minus 2, 0, minus 2, minus 1, x 0. So this is a matrix A which is given to us. We are given that this is a skew-symmetric matrix. A is skew-symmetric. A is a skew-symmetric matrix. We are asked to find what is the value of x. So skew-symmetric implies that the transpose of the given matrix and the negative of the given matrix both will be equal. So one side we will write the transpose of the given matrix. The transpose again is obtained by interchanging rows into columns or columns into rows. So here we will interchange the rows as columns. The first row is written as first column, second row is written as second column, third row is written as third column is equals to minus of A. So minus sign we will write as it is. We will write the matrix A as it is. So minus 1 x and 0. So one side we have the transpose of the matrix 0, minus 2, minus 1, 2, 0, x, 1, minus 2, 0. And the other side we will multiply with minus sign. We have 0, minus 2, minus 1, minus into minus plus 0, minus into minus plus 2, minus into minus 1 is plus 1, minus into x and 0. Again both these matrices are equal. We can equate the corresponding elements whenever the matrices are equal. So the second element of second row and the second element of third row and second element of third row on both the sides. So we can equate, we get the value of x as x equals to 12. So corresponding elements are equated because both these are equal matrices. The corresponding element should also be equal. So by equating both these matrices, any element you can equate, you get the value of x is equals to 2.